Hello students. So we will continue with the previous chapter, that is metals and non-metals. So we discussed about what is ore, what are minerals, and where the metals are found and how they are found. Okay, so here we will in today's class we will discuss about extraction of metals from its ores. What is extraction of metals? To obtain a metal from its ore is called as extraction. An ore contains a metal in the form of its compound with other elements. So after mining of the ore from the ground, it must be converted into pure metal. The ores are converted into free metals by a number of steps which depend on the type of the ore used, nature of the impurities present, and the reactivity of the metal to be extracted. The various processes involved in the extraction of metal from its ores are refining, are called as metallurgy. Okay. Now, as we all know that all the metals, they have different reactivity. All the metals, they do not have same reactivity. You can see here in the even the reactivity series also, the metals are arranged in the order of decreasing reactivity. Now, so the metals at the top of the activity series, that is sodium, potassium, calcium, magnesium and aluminum, are so reactive that they are never found in nature as free elements. The metals in the middle of the reactivity series like zinc, iron, lead, etc. are moderately reactive and they are found in the crust, earth crust, mainly as oxides, sulfides and carbonates. So they are present in the combined form, and it is found that oxygen is the very reactive metal and abundant in the earth. So most of the metals are found in the oxide form. Now, based on the reactivity of the metals, they are grouped into three categories. First, metals with low reactivity. Second, metals with medium reactivity, and metals with high reactivity. Now, you can see here the flow chart for the extraction of ores. Here in the slide, now the metals are divided into three categories. One is the metals with high reactivity, metals with medium reactivity, metals with less reactivity. Now you will see here in the flow chart that the metals with high reactivity, which are the metals which are highly reactive, like sodium, potassium, calcium. So these metals, they are extracted or by electrolysis of molten ore, and by electrolysis of molten ore a pure metal can be obtained. Then we come to metals with medium reactivity. Now the metals with medium reactivity, they are found as carbonate or they are found as sulfide ores. Please see in the slide. Now the carbonate ore is converted into metal oxide. You can see here in the slide, the carbonate ore can be converted into metal oxide or oxide of metal by the process which is called as calcination. What is calcination? Calcination is the process in which the carbonate ore, the carbonate ore is converted into metal oxide when the carbonate ore is heated in the limited supply of air. So that is calcination. So in calcination, the carbonate ore is heated in the limited supply of air and it is converted into metal oxides. Okay. So now then another one is the sulfide ore. Now this sulfide ore, okay, that is converted into metal oxides by the process called as roasting. Now what is roasting? Here the sulfide ore. Okay, first that sulfide ore is converted into the oxide, metal oxide. And how that sulfide ore is converted into metal oxide? By roasting. What is roasting? Roasting when the sulfide ore is burnt in excess of air, or when the sulfide ore is burnt strongly in excess of air, what is formed? Metal oxides are formed. Understood? Now these metal oxides are reduced. Okay, either by heating or by using reducing agent, the metal oxides are reduced to pure metal and then they are purified. So this is the flow chart. I hope it is clear to everyone. Now we will discuss how the metals with low in activity series are extracted. Okay. Now here you can see extraction of mercury. You can see here in the slide also how the metal mercury is extracted. It is clear. Is it clear to everyone? Now, what is the ore of mercury? First of all, ore of mercury, as you can see here in the slide also, the ore of mercury is cinnabar, or it is mercury sulfide, mercury 2 sulfide. So here you can see the ore of cinnabar. Here it is present in the sulfide form. And how the sulfides are converted into oxides? By roasting. Okay, so what is roasting? When they are burnt in excess of air. So here this cinnabar or mercury 2 sulfide, here it is burnt in oxygen. You can see here, and when it is burnt in oxygen, we get mercury oxide. You can see here, plus sulfur dioxide gas is evolved. Now this mercury oxide, it is heated strongly and it is converted into free mercury and oxygen gas is evolved. Okay, I forgot to write the state of oxygen. It is gaseous state. So here what has happened in extraction of mercury? First the sulfide is converted into oxide, and how it is converted? It is converted by the process of roasting. So first aim is to convert the sulfide or the carbonate ores into the oxide ores, and then those oxide in the oxide form, it's converted into oxide form, and then those oxides are reduced. Is it clear to everyone? Now you can also see extraction of copper. Now how copper is extracted? Copper, ore of copper is copper glans, that is Cu2S. Okay, this is also present in sulfide form. Okay, so here also it is converted into oxide by the process of roasting. You can see here copper sulfide is given. It is the state is solid and it is burnt in excess of air, as you can see here. And after burning in excess of air, it is converted into the oxide form, that is Cu2O, and sulfur dioxide gas is evolved. Now this, what happens students here? Here this copper ore, that is copper glans, that is burnt in excess of air. It is roasted, and when most of the copper sulfide is converted into copper oxide, that is Cu2O, then what happens? The supply of air is stopped. Understood or no? Then the supply of air is stopped, and in the absence of air, this copper oxides, it again reacts with remaining copper sulfide. Because copper sulfide is converted into copper oxide, but some of the copper sulfide is left. So when the amount of the supply of air is stopped, what happens? This copper oxide, it reacts with copper sulfide and it forms copper and sulfur dioxide gases evolved. So this is how we generally extract the metals from the ores, metals which are low in reactivity seals. Okay, so I have given one homework, students. So kindly complete that homework and submit the homework in the evening class during the clarification round. And your revision also today, I have given a short exercise on revision also of first chapter of chemistry that you can submit as soon as you finish it in the morning hours. Now students, today I have one very nice inspirational motivational video for you. So just you can see that video. Thank you students.